I think one of the coolest engines the GE ever developed is called the J85. It's like the little tough guy. You know, it was this very small turbojet, actually had an afterburner at one point, serves both commercial and military in very unique ways. When this engine was designed in the 1950s at the Lynn operation, actually its very first application was to power a missile decoy. But the brilliant minds in Lynn very soon figured out they could use this engine for both commercial and military applications. The Northrop F-5 was one of the great small fighter jets internationally in the 1950s and 60s, powered by the J-85. In addition, it had a sister aircraft called the T-38 Trainer, also a Northrop design, which is in operation today with the U.S. Air Force. And then in the commercial world, the very first Lear jets, in the early 1960s, man, everything that was cool was Lear. Frank Sinatra owned a Lear jet. That was the thing. And it was powered by the J85. And that was one of the great sales aspects when they sold Lear jets, these commercial Lear jets. And the idea was it was powered by this shotgun J85 military fighter jet engine. And the J85 had a tremendous run, powering F-5s, Lear jets, its sister trainer, the T-38. And here's the amazing thing about the engine. It goes into service in the mid-1950s. And the U.S. Air Force expects the T-38s to be powered by the J-85 till about 2040. So the engine, which we call the J-85, will likely be in service for all of 85 years. Now that's a little tough guy. When Frank Whittle's son recently toured the GE Learning Center here, he stopped at the TF39 engine, he looked up and he said, "Now, that is one important jet engine." And he's right. The TF39 might be the most important jet engine that GE has ever produced. Certainly changed the entire course of not just our business, but the entire course of commercial aviation. Even though the original application was for a military plane called the C-5 Cargo. The TF39 is what we call the world's first high bypass engines. Now, there had been bypass turbofans around before that, but what makes the TF39 unique is it has a ratio of 8-to-1. What that means is that 8 times as much air pulled through the front fan moves around the outside of the engine as the air that actually goes through the engine. 8 times as much air goes around the outside. The TF39 was a very revolutionary design and required all kinds of technology because you have this gigantic front fan and you had to find technology to pull that thing. The concept really draws from all kinds of GE technologies. GE was involved in early lift fan technology in the 1960s, where you would put 2 fans within the wings of a Ryan aircraft and lift it straight up, the vertical lift concept. That got us involved in fan technologies. And finally, at one point in the early 1960s, we took a large fan, we put it on its side, we attached it to a J79 engine to really drive this concept of a turbofan and high bypass efficiencies. Gerhard Neumann, who was running our business in the early 1960s, was telling the Air Force that we have an engine that could revolutionize transport for both the military and, of course, later the commercial world. And that is what we call the TF39. He would take the same concept. He would put a very huge front fan and then attach it to the most advanced gas propulsion turbine ever made. GE was involved in a lot of advanced metallurgy technologies in the late 1950s and early 1960s that are very, very important to the TF39. For example, there are air-cooled turbine blades in the TF39. That was required because of the temperatures that were being operated in the turbine section, again, to pull this very, very large front fan. 8-to-1 bypass ratio, powering at that time the world's largest airplane, the C-5. GE was awarded that contract in 1965, and what a game changer. Within a matter of months, GE was putting together its own large commercial engine division because sites were already made on taking that TF39 engine that's powering the C-5 transport and take that engine and evolve it into a commercial high bypass engine, which is what we did. because GE was in the commercial aviation game in the jetliner world in the late 1950s, early 60s, with a version of its J79, which we called the J85. It powered the Convair 800 and 900 aircraft. The problem was it didn't sell very well, and so we basically got back out of the commercial engine business. But with the TF39, we're able to come back to the commercial aviation world after the struggle we had with the Convair airplanes. We form a division as the TF39 is being developed for the C5, and by 1968 had fully established a derivative commercial engine called the CF6-6. And we would use that CF6-6 engine to return to the jetliner industry, at that time dominated by Pratt & Whitney. And everything would change when the CF6 family is introduced into aviation in the late 60s and 1970s.